have seen three blocks system. Okay, three block system. Have you seen it, Hemant? Yes, Hemant. Have you seen three block system? Hello.
So we are discussing it, sir.
We were discussing it. Fine. So first of all, what is the first step? First, we will find the common acceleration. Because all the three blocks will move together, M1, M2 and M3. So we will find a common acceleration. Common acceleration A will be given by force divided by the total mass. Total force divided by total mass. This will give us acceleration. Now acceleration of each block will be same because why? Because they all are connected with each other. They all are in direct contact with each other. Okay. So we have got acceleration. And to find the contact force, how much contact force, we need to draw a free body diagram of each of the blocks separately. How to draw the free body diagram? We know that. We just, for a free body diagram, what do we do? Just a minute. This we have seen, right? We need to draw the free body diagram of each of them. So in this case, block A is pushing B, B is pushing back A. Block B is facing force from two blocks, from A in left hand side and from C in right hand side. So we are drawing it F1 and F2. And third one, M3 block, it is facing force from only one direction. Front side is not connected with any other. This will be the free body diagram. So from the first FBD, what are we getting out? F1 means total force minus F1, the normal reaction, equals to M1A. Okay. Done? Yes, Hemant, taken down?
Done, sir.
Fine. Now see this. Find the contact force between the block and acceleration of the blocks as shown. So what will be the contact forces? These red dots between AB and BC. At these points, contact force will appear. And F1 is given as 50 newtons, which is acting in right hand side direction, and F2 is acting in left hand side direction. Means they're pushing in opposite directions. F1 is pushing in right and F2 is pushing in left. Try solving it now.
So in a three-body system, since three bodies move with the same acceleration, we can directly find the force per mass. We can total mass. We can directly write mass.
Yes.
Sir, acceleration 2, sir. And the forces were 30. 36 and 46.
36 and 46. Fine, very good. 36 and 46, and acceleration is 2 meters per second square. How? Again, same thing we did. Total force divided by total mass. Total mass is 10. Total force is 20. 50 minus 30 is 20. Okay, now when we draw the FBD, we'll get two equations and two variables. From that we can easily solve it. Okay. Now next is body connected by string. Body connected by string. Now what is happening here? Instead of direct contact, we are using the help of a rope or a string. But remember one thing, that here rope is massless unless stated. Means rope will not have its mass. But in reality, rope is always having some mass. It cannot be massless because it is made up of matter. Matter and mass are inseparable. Okay. So mass M1 and M2 are connected through this string, and this string can only pull the block. It cannot push the block B. Means you cannot push A from B just by applying force on B and connecting it by a string. String will loosen itself. Okay, so string must be taut always, must be tight always. Got it? Draw the diagram.
So a string is massless beneath as well, sir.
Yes, a string is massless. This is our assumption. Otherwise, what you need to do, in total mass, you must add up the mass of string also. But in that case, tension will not be constant. Tension in the string will be varying. So
Sir,
total acceleration. Yes.
Sir, why sir if the string has mass, tension varies, sir?
Because because each and every point is having its own mass, so that part will require more force to pull. Got it? Force require pulling out, is it not?
Sir, but the mass is distributed uniformly.
Mass is distributed. See, this is the rope, and this rope is having some mass. Here it is 10 kg block. This rope is having mass 5 kg per meter. So after 1 meter, 5 kg mass is added up. Now this point, the tension on this point is responsible for pulling this total mass. Tension here at this point is responsible for pulling all of this mass. Tension here is responsible for pulling all of this mass. So tension is variable now. Got it?
Sir, got it, sir. Sir, copy it, sir.
Copy. And for finding tension, what we do, we draw FBD of each of them. We get some equations along with variables, and we will get what? Our desired result. Fine.
Sir, still got it.
What? Same thing you need to do. Total force divided by total mass will give you acceleration. Now that acceleration is divided up. Yes, got it? Draw the diagram.
Sir, here also that we can do mass by force by total mass, sir.
Earlier also force by total mass we were doing.
Sir, but it's in case of spring also we can do now, sir.
See, spring here, the spring here is what? Hello, yeah, am I audible?
So spring also means what, sir?
See, one
Say
thing. When we draw the FBD, so what we are able to see here, tension is pulling M1 in horizontal direction. Tension T2 is pulling M2 in horizontal direction, and external force F is pulling all these three blocks. External force F is pulling all these three blocks. Getting it, Hemant? So that's why for all three blocks, a separate FBD we must draw. Got it now?
So got it, sir.
Anything else?
So nothing, that's all.
You are asking something else also.
So that's not nothing, sir.
Okay, fine. Now, we will get some equations, and those equations, after solving those equations, we can get the answers. Okay. Now, see this question. Any answer?
The force is potential 120 now.
Force is 120. How force is 120?
The force is not mg plus m due to the acceleration.
Yes, very good. Very good, Hemant. Second, second, what is the force on the rope? How much force must be
So got it.
got it? And third is, what is the tension at the middle point? Now see, tension is always dependent on the other particle which are already. Hello? Yeah, am I audible?
Sir, you're audible, sir.
Yes, now. What is the tension in the middle point? The tension in a rope always depend on the objects which are connected behind, means in the direction opposite to the direction of motion, because we want our string to be always taut, always tight. Okay, so what will happen? Lower part of 3 kg and this 1 kg total will come out to be 4 kg. Now this 4 kg is moving with some acceleration. It means there will be a force. Okay, force multiplied by force equals to mass multiplied by acceleration. Okay, we will get 48 newtons. Next is motion of a body on a smooth inclined plane. Now see, Hemant, tell me one thing, that whenever on an inclined plane you are keeping a block, it will remain there or it will move?
So depending upon angle, it will remove.
Very good, depending upon the angle of inclination. If the angle of inclination is very, very less, it will not move. But if the angle of inclination is gradually increased, then what will happen?
It will slide down.
Huh? Yeah, it will slide down. Fine.
Yes.
And because of which reason is sliding down? Because of gravity. Gravity was always pulling it in downward direction. That's why it will be having an acceleration A equal to G sine theta in downward direction. So mg sine theta, mg cos theta will be what? Mg cos theta will be our normal reaction, and acceleration in downward direction will be what? G sine theta. Take it down. Is taken down.
So copy it, sir.
Copied. Now, see this example. See this example.
Sir, this one not getting to this contact force.
Why?
That means it will be G sin theta, we can write this.
See, angle of inclination is same in both of them. Okay. Angle of inclination is same for both of them. So what will be the total force? The normal reaction between the two blocks must not exceed this particular limit. Getting it? For the blocks to slide down. Sorry, for the blocks not to slide down. Getting it, Hemant? What I'm trying to say? Hello? See, Hemant. Hello, am I audible?
Sir, your order is good.
We need to find out the contact force. So here this line is in contact with one another. 2 kg is applying force on 4 and 4 will be applying on 2 kg. Okay. And because of the gravity it is going in downward direction. This will have an acceleration of acceleration of g sine theta. This acceleration will be of g sine theta.
Yes, sir.
Got it thus?
Sir, got it. Sir.
Now, next is pulley block system. Pulley is what? In pulley, one end of the string passes through the pulley and connected to 10 kg mass at other end and is pulled by 100 newtons of force. Find the acceleration of 10 kg mass. Try solving it fast.
Sir, 0.2 now, sir. You got, sir.
See, to do this?
So got it.
What is the technique to solve?
So there is the tension upward.
Yes.
The force will be in the upper and variably down in muscle.
Fine. And why is that happening? This is to be remembered. Why is this happening? Because the string which we have taken is inextensible.
Yes, sir.
Okay. It is not stretching itself as a rubber band. So the length of the string will remain constant. If length is increasing, then what? Then the pulley is not massless. Okay?
Yes, sir. Okay.
Like, find the acceleration of each block. Find the acceleration of each block. Try it out. Yes, Hemant, any answer?
So this one not getting, sir.
See, Hemant, again, see one thing. The tension I have written here already. Tension are not there in this question, only this thing was. We know one thing, that this block is of mass 2 kg and this block is of mass 4 kg. So let us consider that acceleration of A1 is of 10 kg. It means what? It means the string is same. So this string will have an acceleration of A1 but in opposite direction. Okay. Similarly, for this part, we took the acceleration as A2 and for this part we took the acceleration as A3. And we took as if the both are going in upward direction. Okay. Now we have accelerations. Now what is the relation between the accelerations? A1 plus A2 by 2 means A2 plus A3 by 2 will be equal to A1. Okay. And now let us draw the FBD of each and every block. For 10 kg mass, 2T and 10G, acceleration is A1 in downward direction. We have seen. So one equation we'll be getting. Similarly, for 2 kg mass, we will get another equation. Take it down. Take it down up to this point. Done, Eamon? Done till this point?
Done, sir.
And for third block, we are getting this. Third block of 4 kg will have FBD like this. So 3 equations we are getting, and this equation I was already saying. We know this A equal to A2 plus A3 by 2. So these 4 equations and 4 variables we are getting. Solving all of them, we will get these answers. Okay, equation solving you can do it on your own now.
Yes, sir. Okay.
Okay, taken down.
Sir, taken down. Sir, tomorrow there is thermodynamics class or not, yes, sir?
Thermodynamics class, yeah, it should be there, but I don't know what happened to Anshul. He's not picking up the phone. I'll confirm it with him. Otherwise, we will continue.
Yes, sir.
Yes, Eamon. Same thing is there in this question also. Tension in the string will be same, so tension is T. And because the string is tightly wound, and one end of the string is fixed. So fixed end will have zero acceleration. The acceleration with which m1 is coming towards right, same acceleration, the pulley will go down. Is it not? Evan?
Yes, sir.
No, it is not. Please listen carefully. Pulley will go down with half of acceleration. A1 plus A by 2 will be equal to A2. Got it?
So its whole system will go downwards, sir.
Yes. So again, we'll draw FBD of each and every block, and then we'll get some equations. Okay. After solving the equations, we'll get A1, A2 as following: 2m2g upon 4m1 plus m2 and m2g upon 4m1 plus m2.
So got it.
Got it? Now, take down the next question. Take down the next question.
The question got it, sir.
Got it? Okay now. That's it for today. Okay. From here we shall continue tomorrow. Okay.
Yes, sir. Office.